In this lecture, we are going to discuss the conversion of reactant into product. Now, first of all, what is conversion? In the case of irreversible reaction, suppose we take a batch reactor and this is batch reactor. Suppose we take a batch reactor. We put some reactant A into the batch reactor. After a certain time, in this reactor, after 2 hours or 3 hours or 1 day, the reactant A converted into product. But the A is not converting 100% into product. Some of the A will be present in the last of the reaction in this reactor. So suppose first of all we put N0 mole of A into the batch reactor. Suppose we put 20 mole of A, 20 moles of A into the reactor, which is represented by N0. At the start we put 20 mole of A into this batch reactor. After a certain time, the reaction was taking place. The reaction took place, and in the reaction 50 to 5 mole of A consumed. In the reaction, during this reaction, 5 mole of A consume or converted into product. So in N0 mole, in N0 x mole consumed is denoted by in N0 x, which is 5. At the start we put 20 mole of A of reactant A. At the start we put 20 mole of reactant A into this reactor. During the reaction, 5 mole of A consumed and converted into product B. So now what will be the mole of A present after the reaction in this reactor? It will be simply 20, which was initial, and minus consumed. 5 was consumed. 20 was entered to the reactor at the start. 5 was consumed during the reaction. So what will be after the end of the reaction? At the end of the reaction, how many mole of A will be present in the reactor? It will be simply 20 minus 5, which is 15 mole of A will still present in the batch reactor, and which is denoted by A. So Na is nothing but it is initial mole of A minus mole of A, which converted into B. So from this relation, from this equation, we can derive the conversion of A, that how many mole are converted into, the conversion show that how many mole of A converted into B. So from this equation we can define the conversion of reactant A. So we will define the conversion in the case of batch reactor, which was N0 mole was entered at the start of the reaction. N0 mole was entered into batch reactor. N0 x mole of A was consumed during the reaction, and Na mole of A was still present in the reactor after the completion of reaction. It means that n0 mole of A will enter into the reactor, and n0 x mole of A will convert it into product. Then how many mole of A will be present in the reactor after the completion of reaction? So it will be n0 minus n0 x. So from this we will derive the conversion of A, which is Na is equal to n0 minus n0 x. So it is Na into 1 minus x, simple mathematics, Na. Or we can also say that Na divided by n0 equal to 1 minus x, which is equal to x is equal to 1 minus Na divided by Na naught. The Na was high and it was small, so conversion is always less than 1.